video is a continuation of Summer School Algebra 1, Unit 1, Lesson 3, Solving Equations and Inequalities. Today we're going to review really quickly how to solve an equation and then extend that those skills to solving inequalities. Okay? So let's review how to solve an equation for the value of x. In example 1, I have negative 4x plus 6 equals 22. Now every time I solved an equation, I started by organizing and drawing a line down under the equal sign. In order to solve an equation, I think about inverse operations. So when I look at the positive 6, that has an addition sign in front, so I need to subtract 6 from both sides so that I can get x by itself. When I do that, I end up with negative 4x equals 16. Okay? Now I have negative 4x, and the negative 4 and the x are being multiplied together. So to undo multiplication, I have to divide by negative 4. When I divide by negative 4, I end up with x by itself equals negative 4. So x equals negative 4 is my solution. Now in the direction that says graph the solution on this number line provided. So if I have x equals negative 4, I end up putting a dot on the number line at negative 4. There is only one solution to this equation. Negative 4 is the only value I can put in for x that gives me 22 as an answer. Now we're going to follow those same steps going forward, but this time we're going to have inequalities. Now inequalities are symbols in math that look like these down here. All right, this first symbol, we call that less than. The second symbol is less than or equal to. Then I have this next one is called greater than. And the last one is greater than or equal to. Now the difference between the greater thans, the less thans, and the ones that say equal to is that the symbols that have the equal to have a line underneath. That line is like half of the equal sign from an equality. When I'm solving inequalities, there's one thing you probably remember from middle school. It's that really important thing right here that's centered. It says that if we multiply or divide an inequality on both sides by a negative number, so if I multiply or divide by a negative, I need to flip the inequality sign. This is really important. We don't want to forget that. Okay. Now there are special kind of dots that I'm going to put on my number line when I have these different inequality signs. Anytime there is what we call a strict inequality without the line underneath, my number line is going to have an open dot. So both of these strict inequalities are going to have an open dot. When there is a line underneath, the inequalities are going to have a closed dot on the number line. Okay? Now, if you're having trouble remembering which symbols are less than and which are greater than, here's one way to try to think about it. These less than symbols here look like this. If you look at that a little carefully, it kind of looks like an L that has been smushed together a little bit. So L is for less than. These symbols on the right don't look like L, so they're for greater than. Let's get to a couple examples here. In example 4, it says, given the linear inequality 4x minus 3 is greater than or equal to 5, do the following. First is to solve the inequalities and find the solution set. All right, the solution set are all the possible answers. So to start, I'm going to write the inequality that it was given to me. 4x minus 3 is greater than or equal to 5. Just like I did when I solved equalities, I'm going to draw a line down. The only thing I have to be careful of is I'm not going to draw an equal sign anymore. I'm always going to do the greater than or equals to 5. To solve here, I'm going to start by adding 3 to both sides. And I'm going to end up with 4x is greater than or equal to 8. Not equal, greater than or equal to 8. Now to get x by itself, I divide by 4 and get x is greater than or equal to 2. That is my answer. Now when I look back at the previous page here, when I have a greater than or equal to, it says I'm going to use a closed dot. So I'm going to put a closed dot on 2. Now I have to think about what the inequality says. It says x is greater than or equal to 2. So greater than, I need to figure out, are the numbers to the left over this way greater than 2, or the numbers to the right? Well, it turns out the numbers to the right of 2 are greater than it. 10, 5, 3. They're all greater than 2. So I'm going to shade my arrow to the right. That's called the solution set because any number 2 or any number under the shaded region to the right all make this inequality true. Now the question, how many solutions are there here? It turns out there's infinitely many solutions. Right? There are infinitely many numbers that are bigger than or equal to 2. So there's infinitely many solutions. All right, 2 more examples on this page. Let's solve 8 minus 2x is greater than 16. I'm going to start by putting my line down the middle, and I'm going to end up moving the 8 first. This 8 is positive, so I need to subtract 8 from both sides in order to get x by itself. When I do that, I end up with negative 2x is greater than 8. Now, in order to get x by itself, I have to undo the multiplication by dividing by negative 2. When I divide by negative 2, an alarm should be going off in your head. Oh, I'm dividing by a negative, which means that I have to flip the inequality sign. So I now have x is less than negative 4. That's my solution. So when I go to negative 4 on my number line, I need an open dot this time. And all the numbers that are less than negative 4 are out to the left of it. All right, last example here in B. I need to start by distributing the 3 to both terms in the parentheses. When I distribute the 3, I end up with 3x minus 15 is greater than or equal to 6. All right, to solve this then, I have to undo the subtraction of 15 by adding it to both sides. That leaves me with 3x is greater than or equal to 21. Now, in order to get x by itself, I need to divide by 3. But this time I'm dividing by a positive 3, so the symbol, the inequality symbol, is going to stay the same. I'm going to have x is greater than or equal to 7. So I'm going to go to 7 because there's the equal sign here under the inequality. I put a closed dot on 7, and all the numbers that are greater than 7 are to the right. Okay? Short notes, but all the steps are very similar to solving equations. All we have to do is how do we mark the number line, what kind of dots, etc. So go ahead and do some practice that's posted on Canvas. There will be a practice video posted as well for your questions.